And thank you everyone for attending. And well, the subject of webinar is how to evaluate crosstalk in high-speed PCB interconnects. So, as Lucy mentioned, there are a lot of slides, so let's get started. After some introduction, I will talk about a little bit only about anatomy of crosstalk and traces. And then the main subject of this webinar is how actually measure crosstalk, or rather numerically evaluate, maybe measure even, and what metrics to use to quantify it. So, and this webinar is based on the recent tutorial that was at DesignCon 2025, and slides are available. It was 3-hour tutorial, so the only part, 1/3 probably, I will cover today, relevant to the quantification only. So if we consider different effects, different signal degradation factors, so I put them in 4 broad categories here, and absorption is absorption of signal energy in dielectrics and conductors, and there are some application notes at Simbeor website explaining how it happens and how to simulate it. Application notes are located in application notes section of Simbeor website. Reflections, this account for different types of reflections, from impedance mismatches, from discontinuities, and those two are probably the major reason for signal failure. So, but we will not talk about them today. You can read in application notes again, reference here. So today we will talk about leaks and dispersion, or dissipation, rather into other interconnects. It's a broad subject, usually known as crosstalk. So leaks from some links appear in other links as interference from in form of interference. So in brief, crosstalk is unwanted noise from the coupled structures caused by signal leaks that degrades the useful signal and may reduce the data transmission rate and even cause complete link failure. So crosstalk is usually not the #1 reason for failure, rather number maybe 2 or 3. But it is important nevertheless. Why it is important? Well, first of all, PCB and packaging interconnects are open waveguiding structures. I keep repeating this because of it's not obvious, and I put a few slides and even a little demo of the fields later in this presentation, just to explain what I mean by open waveguiding structure. So it cannot be corrected at the receiver in general. So there are techniques for synchronous signals, how to deal with this, but in general for serial interconnects, it's not possible. Neglecting crosstalk, well, may cause failure, and we have such designs from our customers and partners that basically failed because of crosstalk, and finding it and fixing was a big deal. Crosstalk is deterministic. It's not just random noise. It's difficult to predict. Why? Because of its uncorrelated noise, so it's bounded. That's important item here. Direct analysis in many cases is costly or inefficient. But the worst case analysis may lead to over-design. Understanding the sources and mitigation of it is very important. So I hope everybody understands this who attended this webinar. So considering crosstalk types, we can separate them in two categories: as local coupling and distant coupling, and also known as multipath propagation. In local coupling,